Today, I will present the band switching solution developed by KYOCERA AVX. The main challenge that all NB-IoT and LTE Cat-M band is facing nowadays is to have good antenna performance on small PCBs. This problem is even more important on the low band, and this is the issue that the band switching solution is targeting specially. Using KYOCERA band switching solution and antenna allow devices to maintain good performance even when their PCB is small. Now, let me show you the boards. We have the passive 1,047,095 antenna EBV, which is 45mm by 125mm. We have the antenna, the SMA connector, and the matching circuit. Here, we also have the passive 1,047,095 antenna EBV, but with smaller dimension. Indeed, this one is 45mm by 60mm. On the other hand, we have the active 1,047,095 antenna EBV that is also 45mm by 60mm. We have the antenna, the SMA connector, the matching circuit, the tuning components, and most important, we have the switching system that will allow us to choose the frequency band of our choice. This system is using the KYOCERA AVX EC646 switch and two jumpers. Depending on the state of the two GPIO signal, the complex impedance load connected to the antenna parasitic element can change, allowing the user to choose the frequency band needed. Now, let me show you how it works. Here, we have the passive 1,047,095 board that covers the low band frequency from 700 MHz to 900 MHz and the middle band frequencies from 1710 MHz to 2170 MHz. What you can see is that the return loss in the low band frequency from 700 MHz to 960 MHz is much below -9 dB. Now, if I connect the shorter passive board, what you can see is that the ripple loss in the same band is now quite less good. Indeed, it's now much below -5 dB. And here we have the 1,047,095 EC646 antenna band switching active board, which has the same size than the short passive board. The performance of the middle band is very similar to the passive board. What is different is the low band performance. With the state of the GPIOs being at 0,0, we cover frequencies from 890 MHz to 960 MHz. By changing the state of the GPIOs to 0,1, we see that the frequency band is now going from 700 MHz to 800 MHz. Again, changing the state of the GPIOs to 10, we see that the frequency band is now going from 700 MHz to 750 MHz. Finally, if the state is 11, the frequency band goes from 790 MHz to 890 MHz. And you can see that the mean of the return loss within each of the subparts of the low band is improved compared to the passive version. So, with KYOCERA AVX band switching solution, it's possible to recover good performance over all the low band, even on a small PCB. For more details, you can find the datasheet of the 1,047,095 EC646 antenna band switching on www.kyocera-avx.com.